So, all right. Good morning, everyone. So, welcome back to AI-based decision support one second lecture. So today we're going to dive into the topic a little bit. So last time was organization and some, let's say, smooth introduction on the context of AI-based decision support. So why we actually need it, what we're going to do with it. And today we're going to distinguish some really important concepts like machine learning and part of analytics, what's different to statistics. This is very important since our goal is to always place what you do within the context of your whole course of study. Since most of you have an economic background, and even if not, you will apply it to real world problems. So a context is always important. Having said that, we will hopefully end the lecture with talking about business understanding, which is the first step of our whole process that we will undergo through this lecture. So this gives our lecture structure. Before we start with the learning goals for today that you can see on the slide, you might have noticed that I played some music to wake you up. So this was no coincidence, or I didn't leave the music on and just headbanged here without my cam. This was not the case. I enjoyed the music, but why I did this is because the music you just heard was completely AI generated, right? So and I found it was pretty good, and there are a lot of examples about that. And I promised you we would have also sometimes a non-technical scope, and usually I want to start with that because it's very easy. We can ease in. Everybody can wake up. Everybody can get a cup of coffee. So will like be the first 5 minutes, a little morning talk, so to say. While the technical side of AI-generated content is pretty well, technically pretty hard to understand, and it takes some training to understand. We will get there in AI-based decision support 2 for text. We might also give a little idea on how to generate images and music, but only very briefly, so maybe 10 minutes each, because it's very difficult to explain it in a general way that would fit the audience here, right? So we have a large audience here, and so we need to like cater a little bit towards that. So it sometimes is it's a little difficult to do that. And so, but don't worry, we will try to do it. But obviously, that was the wrong one. Sorry. Obviously not today. But we want to talk a little bit about this side of AI, the generative AI that has had like a real rose with a ChatGPT developments that everybody can use, and there are a lot of tools now. There are a lot of foundation models to generate text to help you out. There are some problems with that, so we will also talk about that. But so my first question is to get you involved early on here. So you heard the music. I know it's not everybody's type of music, but I found from the quality side, it was pretty good. And if you like, in your honest opinion, my first question would be, did you suspect it was AI on any level when you heard that? Or did you just think I was gonna wake up and play to you some music? So just say yes if you thought it was AI, and say no if you think like it wasn't AI. Just hard to move the mouse here. No, okay. Not really. Yeah. So this was what I kind of suspect. I didn't suspect it either, to be honest. So friend sent me this. He's introduced more into this kind of music than I am, but I occasionally listen to some somewhat rock guitar heavy music. And I found it quite nice. And then later he on his own discovered, oh, this is AI, right? So this was AI based. And then the funny thing that happened is, and this is what actually inspired a research project we are doing right now, was that he had now mixed feelings about this, right? So he said this is beautiful, nice lyrics, it's a nice sound. He likes this kind of music, so I believed him. However, after he read about it, so he listened to the music first without any like disclosure whether it was AI or not, and later on he had mixed feelings about this. So he didn't have mixed feelings about the quality, but about other parts of it, like how he could appreciate it. And I think this is the tricky part in our research project right now. So to get you a little bit updated is to distinguish between the different notions on how we can perceive art, right? And how our perceptions in other categories, like we have quality, how much would you pay for, creativity, and all these things that we can like assess. So how do you assess art? When you listen to music, you say, okay, I like it or I do not like it, but there are actually a lot of things that happen that you come to this decision whether you like it or not. It could be that you say, "Oh, I'm thinking this is very creative, this is very complex, but I don't need to actually like it, but I can say, hey, this is a good piece of art." So, but you don't have to like it, but you can see that has a lot of technique. For example, when you hear a really difficult piece of music with a fast guitar like Van Halen or Dream Theater, or when you hear a classical piece of music, right? You hear a classical piece of music that is very difficult, like Paganini or something like this. When someone plays it on the violin, it's very difficult. It's a masterpiece. What's a hard piece to master? So it's not only rock, but any type really. You can appreciate that it's technically well made. It's difficult, but you do not have to really like it, right? So our question was, what would the disclosure of AI do with the humans, do with these different categories on how they perceive art, right? So this is like an interesting question. And when you go out of this lecture today and drink maybe your second coffee, I want you to think about that. What would that change with you? Now, you can also write a little bit in the chat if you like. So would this, like, for example, now, let's take this example. So I just played you the music and let's say you didn't, it could be that you didn't like it because it was not your kind of music, which I totally understand. So I want to know, did whatever your perception of the music was, you liked it, you did not like it, did my disclosure that I said, hey, this was AI, changed anything? Don't have to say if it changes a lot, but did you think about it? Did this made something with you? Did it affect you in any way? Just type yes or no. We won't go into detail. As I said, it's very complicated since there are many aspects, but I just want to know, because this is what you study, right? This is like this is not AI-based decision support, but this is basically AI-based decision making. So the AI does the decisions, what to compose, what to generate. So, oh yes, yes, no, 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 yes. Oh, there are quite a lot of yeses. So this leads me to believe that our research project actually somewhat has a point. We will see what the yeses or nos are comprised of. So we will see what kind of things change, what will not change. So this is very interesting because it was always for me a question on how people would perceive this in all of the dimensions, right? And I think this is quite interesting. But now we want to go back to our lecture. So this was our morning talk. Thank you for joining. And now what we're going to do today, right? So we have two learning goals basically today. We actually have a third, as I said, business understanding, but this is later. So these are our prime learning goals. And if we make it to the third one, there's also a third one. So don't worry about it. But I don't want to promise it right now. So first, what does machine learning mean? What's the like idea, the basic idea? And this is kind of important, not kind of important. It's the basic concept. If you understand this, first of all, on a non-technical level. So we will start out today on a non-technical level. We will use an analogy. I also updated the slides to put the analogy in. So as I promised to have more slides about things and not like have the analogies just said, so that you can actually understand what I'm saying and you have a slide where you can relate to, so that you see that we listen to your feedback. So what does machine learning mean and how does it differ from other forms, right? So, and this will be, we will looking at quite excessively. So we will also have a look at the machine learning concept, and then we will have the concept of different analytical forms. Now, these are not the same concepts, right? But they are very, they are familiar with each other. So it's like they are related to each other in some way. So we need different techniques for the different types of analytics. And so the different types of analytics is very important for us, since some forms of analytics are actually the source of our data. Some are what we do, the predictive analytics. We predict things, right? And some things are specifically done to do decisions, right? To make decisions. So when, for example, the computer makes a decision, which is called prescriptive analytics, right? But we will talk about this later. Then we talk about the CRISP-DM process. This is particularly important because this will guide us through the lecture. This is like our syllabus, right? This is our structure for the lecture. So we will be there. I also showed you a quick preview in the last lecture, but we will go there a little bit more specifically and talk about what each step does. And then we will talk about each step into detail in the upcoming lectures. All right, let's dive into this. So this here is a picture or an image from this read. So you have two readings. One of the reads is read 01. You can download it in the e-learning. If you like to know more, I highly recommend reading this. Not only because then our reading numbers will go up because we actually wrote this paper, because we found we needed like a very much a non-technical introduction to machine learning, right? That is more in the information system context. So that's more in the larger context. This is what we try to convey today. So basically, the idea of machine learning. So we're going to start with the analogy, and then we're going to go back, and I'm going to map the things I just showed you onto the analogy, right? From the analogy to the actual theoretical overview here. Okay, so the basic concept of machine learning. Okay, I want you to imagine the following example. Okay, I want you to imagine that a mother right here wants to teach a child, the child is right here, what a sports car is. So that the child is able to go on a parking lot with cars the child has maybe not seen before, maybe has seen before, to determine for each car, this is a sports car, yes or no. So the decision, remember, we talked about decision support, and we always remember, this is not just like we're going to skip everything we learned the last lecture. So the decision here is very easy. Remember the decision with the solar panels. So here, the decision could be based upon this information, or it could be the decision itself to decide this is a sports car, yes or no. But usually this is an information that helps make decisions. So if something is a sports car, yes or no, the idea is would we call someone and say, hey, I found a nice sports car on the parking lot. Are you interested in that? Then you can buy it, not steal it, right? So this is not gone in 60 seconds, but could also be a case like people are just looking at cars and just saying, hey, but this is obviously an illegal activity, so we're not going to promote it. But in this case, the question is, so the child sees a car. This is the input, right? The input is, so the child looks at the parking lot and says, okay, this is a car, this is a car, this is a car. And then the task is to say sports car, yes or no. So the question is now, how can we enable the child to do that, right? So this is our goal. This is our end goal that we have, right? This is the task. So now there are two ways, exactly two ways we can do this, right? Or the mother can do it, right? So the first thing the mother can do is it can prepare something like a decision tree and say, okay, first of all, you look at the tires, you look at the rims, then you look at the color, right? Then you look if it is a very flat car and so on. So it basically, the mother basically hands out a list to the child, right? Or a decision tree and says, if you follow this exactly, and at the end it says sports car, no sports car, no sports car. So it follows down the tree, and at the end of the tree, it says for every node whether it's a sports car or not a sports car after the child followed a path after checking the input car, right? So first checks maybe checks the tires, checks the roof, checks the hood, checks the color, checks the height, and so on. And then say, okay, if this is that, if this is that, if this is that, then it's a sports car, right? This is the first thing. And this is called explicit programming. So explicit programming is when we completely decide and explicitly state what a sports car is. Now you find this everywhere. You find this in physics, where you have the law, where you say, okay, This is calculated based on that. So E equals mc square, for example. This is an explicit programming. If we want to get E, we need to put in M and C and square it, right? So we need to only square the C. But so this is explicit programming, means we have a formula ready that we can use, or a decision tree or whatever. But it's an explicit rule. It could be like an equation, it could be a decision tree, whatever. But it's an explicit rule that you can actually give someone, or you can even let it like have it done by a PC or something that is very easy to execute, right? Given that the child understands like what rims are, given that understanding, we just assume that this understanding has been given to the child. All right. Now, the problem with that is, and you can imagine, now I want you to try to think about how would you write that list? How would you do that, right? And because a sports car is not a concept that is very particular. So if the question was like maybe distinguish a square shape from a circle shape, this would be maybe easier. You can use other rules and it would be easier, but sports cars are very different. But these tasks appear. Like we have to compare in computer vision, which is the field of like putting an image into a computer and getting an automated decision on it, like whether it's a boat, an elephant, whether it's a person. We want to count persons, we want to count cars on the highway. This is all automated. So this is the same thing. So we look at an image and we want to determine what it is. And here the task is sports car, yes or no. So the first thing, explicit programming. It's not that easy as it sounds. Now, when we have it and it works, it's really nice, like physical laws. We actually know that this is the law, we can apply it and it will always work. It's very beautiful when it works, but it's very hard to do. So the other thing we could do is, in order to make the connection between the car and the output. And this is what you have to visualize. What the child does is it makes the connection. This is why there is an arrow here between the input that it gets and an output. So the output in this case is binary, right? So the child only has to say sports car, yes or no. So this is what we call a classification. Talk about this later on, but just so you have heard the word. So it could also be that we put out a number, like how much do you think this car is worth? Could also be a task, right? Also no problem. This would be a regression. However, for our task, I kept it simple, sports car, yes or no. So if it's a sports car, yes. If it's any other car, so we really don't bother if it's a truck or if it's a monster truck, if it's a small or a family, like a family truck or whatever, we don't care. As long as it's no sports car, it goes into the no category. Also very good thinking. This is what is called one versus all classifiers. You don't have to remember this, but I'm just saying, based on this concept, you can easily understand how we do multi-class classification if we not have binary but multiple classes. We put everything into one class and then we have the interesting class here. Okay, but now how do we do this? So how do we make the connection? Well, one thing is explicit programming. So we say, okay, you look at it, you look at all the properties, and then at the end, you will get a yes or no from the decision tree, for example, or from an equation, right? You get a number and you can say, okay, if the number is larger than 0.5, then it's yes, smaller, whatever. So, but this is very, as I said, it's very hard to do. So the other thing that we can do is actually, we can do something that you also might do when you prepare for an exam. And this is we learn. We simply learn. The process of learning. We all learn. You have learned, right? This is a master degree program. So I'm guessing you have learned something before and wrote a bachelor thesis and so on, wrote some exams already, went to school. So we've all learned. And learning in this case basically means that we say, okay, listen, I'm going to give you a lot of examples with solutions. So when you prepare for a math exam, what you do is you look at the task, you fill out, and you calculate your solution, and then you compare it to the solution that has been given to you for like for the mock exam, or you have a lot of old exams and then you do it, right? Then you compare it. And if you made a mistake, if it's not the correct answer, then you have to go back and change the way you approach the task, right? So you have to adjust yourself until you get it right. This is what learning does. And this is the exact same concept how machine learning works. It's even a little bit simpler because in a math exam, you will have some previous knowledge gain, but you will have it gained probably from people that show you how to do it, right? So also example and solution, example and solution. So here it's just about the input and the output. So what the mother does is takes the child by the hand. In the case of machine learning, or the case of learning, child is not a machine, sorry. Just an analogy, okay, guys? So sorry. Takes the child by the hand and they go to a parking lot. They go to a large parking lot, so larger than this, like can't fit it all on the slide. So this is just an example. Go to the parking lot, takes child by the hand and says, starts with the first car. And the mother tells the child the solution to the task, right? And says, hey, this one right here, this is a sports car. Then the child looks at the car, okay, all right. Goes to the next car and says, this is not a sports car. Goes to the next car, this is not a sports car. Goes to the next car, this is not a sports car. Always the child looks at the car, tries to figure out. Goes to the next, this is a sports car, right? So as you see, the greens are sports cars, the reds are not sports cars. And this goes on, not only for 5 cars, but hopefully for a lot more, right? So, and you can already guess from this a lot of problems. So we can use this analogy for every single problem that is there in machine learning. And a lot of problems have to do with the parking lot, as you might imagine. Like I know that you're already thinking, but how many cars do we need, right? Be honest to yourself. A lot of you just thought, how many cars do we need? What's the good number of cars? Well, we will get to this, but it's a problem. And also, when we're looking at this, just look at this analogy, right? You forget machine learning, and I don't want to know anything about overfitting or don't try to be clever here. Just use the analogy. So just child and mother, okay? And use this approach, this learning approach, where mother goes with the child through the parking lot. What kind of problems do you think could hinder the child's learning? Please use this analogy. What kind of problems? Just think about it. Just as a human, think about what could be a problem. I think I mentioned already one, but what kind of problem? In the parking lots, every problem doesn't have to be the parking lot. Could also be the mother, could be the child, whatever. So there could be problems with the parking lot, there could be problems with the mother, and there could be problems with the child, right? So just think about this. Red non-sports car. Okay, I get what you do. Normal looking sports car, maybe. Okay. So these are parking lot problems, right? So what you're saying is that this one right here, this one actually could be that it's not a sports car, right? And then it could be that this one here that is pretty normal looking could be a sports car, right? Cars that don't fit one of the categories perfectly. Oh, that's the beauty of it. So we say sports car. Okay, it could be that for example the sports car is hard to define, but the no category is everything else. So the no category is everything but a sports car. So they don't need to fit any description. But yeah, I see this is a very good point, actually. So you made a very good point against explicit programming, because this, whether it fits or not, we kind of circumvent this by saying, hey, this is a sports car and this is not a sports car, right? But what is the problem, right? There's another problem in what I just said. Okay, let's see. Cars don't fit one category perfectly. So this is pretty cool. Then this tells you why explicit programming doesn't really work here, right? Because what do you do with cars that don't fit? Like, I can circumvent it and say, this is a sports car, yes or no, but what could happen? So think about the mother. You're thinking about the parking lot. Now think about the mother a little bit. Because what does the mother do? I illustrated it here. What does the mother do? Modify tuned cars? Yeah, of course. So all parking lot problems. But what the question you have to ask yourself now, what you did is you observed everything, right? But what does it mean? Like, what is the implication of that? Like, you need to go one step further, and this is how we train analytical thinking. So all the examples are really nice. For example, normal looking sports car, maybe. Okay, red non-sports car, modified tune cars. What does it mean? If you use this image, what does it mean? Now the child needs to learn. So what does the child need? It needs correct examples. Now think about this. Okay, only red cars are sports cars. Every red car is a sports car. Oh no, this is a white car that is a sports car. But yeah, I get your point, right? So if I take this color thing, yeah, the mother is teaching the wrong features of a sports car. The mother, very important, the mother doesn't teach any features here in my analogy. We will talk about this a little bit, so it's cool. So it's actually a nice point. We will talk about this in a second. So this is a problem. This is a problem. So remember that in my analogy, it isn't a problem because the child looks at the sports car. The mother doesn't say anything about the features of the sports car, right? However, your point is very interesting for when we map it to the theoretical thing. So keep that in mind. So thank you for bringing that up. Okay, let's continue reading the chat a little bit. Sorry, I have to put my mouse on my second screen all the time, so I may want to put it here. Okay, let's go. Only red car, the mother is teaching the wrong. Yes, of course. Does not say why it's not a fit, why it's not a, okay, does not say. So there's no explanation why the mother said, the mother just says is or isn't. There's no explanation. Yeah, that's right. That's another problem. Mother doesn't have enough knowledge. That's great, actually. Yeah. So what does that mean? Now, what you all say is very cool, but now you need to make implications to reflect it on that. So what does it mean if the mother doesn't know? What does it? So our goal is that the child can do that the child can say sports car, yes or no. And what you now need to do is you need to take your point. You need to take your point that you all made valid points. Everything is correct, but you need to now derive implications of that. And this is how it's done. You make a normal observation like every human being can. But now you have to see what does that mean for the learning process, right? So mother doesn't have enough knowledge, totally correct. What makes the mother an expert? Yeah, this is like almost the same, yeah. Mother's not knowledgeable. Yeah, okay. Only visual aspects are covered of the sports car. Correct. If the child looks at the sports car, the only data the child has is the visual aspect of the car. Totally correct. Incomplete data. Yeah, this would be the same, right? So either incomplete features or we don't have. Yeah, that's also a good point. If a mother does not know, she can train kid wrongly. Yeah, child will copy exactly the mother. Absolutely. Insufficient data. Absolutely. Okay, so all your points are very valid. It's very great, and we will exactly use your points to address problems. We will not address every problem today. We have a lot to do today, but I will remember what you said in that I will save the chat, and then we will go back to this. And but what I want you to do is you can practice after the lecture when you like have a second cup of coffee or when you're outside walking. I want you to infer some of the implications of what you just said. So some of you already said if the mother is what makes the mother an expert, mother's not knowledgeable. So, but the mother, what the mother says, the mother gives the solution, right? So the solution, the mother says this is a sports car. So the child, as you said, copies exactly what the mother does. That means, of course, the child knows nothing. The child learns. So totally depends on the mother, right? Totally depends on the mother and depends on the parking lot. So if the mother's not an expert, if the mother gives, if this is wrong, what the mother says. So for example, if says, okay, this is that is not a sports car and the green one is a sports car. This is a problem, right? That means this, what the mother does here, saying this is a sports car, is called labeling, right? So we label it. Labeling means we give the solution. Like in a math task, if I make a mock exam and I give you the solution, I label this, right? I say this is the solution or whatever, right? So this is called labeling. And if the labels are wrong, this is a sincere problem, because what we assume in machine learning always, right? We can work on this, and this is why we don't start the process at the machine learning model, but at the data preparation and at the business understanding, is that this can be wrong. The data can be falsely labeled. Exactly right. So the model there are some problems with the model, obviously, right? And there are some problems with the parking lot. You also named like incomplete data. We will learn this in data preparation, the orchestration of the parking lot, right? So you could, for example, assume that the goal is actually to detect sports cars here more than it is to detect non-sports cars, right? So this is kind of always an idea that the positive class of interest, like detecting cancer, detecting fraud in credit card fraud. So we're not really interested in seeing the non-frauders. We want the fraudulent people, right? So, and if there is less sports cars, then, or the parking lot doesn't consist of enough sports. So there are a lot of problems here, right? And something I want to take was one comment. Biased data not necessarily representative. Exactly, that's exactly the point. There was one thing that I was looking forward to that actually came up. What was it? The model specifies sports car, models not knowledgeable, visual aspects are covered. Yeah, so Tarek said that. The mother, I hope I pronounced her name correct. If not, I'm very sorry. The mother is teaching the wrong features of a sports car. This is very interesting because we have the word features in it, right? So we have the word feature in it. And do I have an actual animation? Yeah. And this is pretty cool because we have words for this, right? And the word feature came up. So thank you for bringing it up. So we don't need to go into detail right now what it is, but the important thing is that when we train something, what we do is we always give input and solution. So you can always remember task and solution. So, or not task, let's say, the exam task and solution, car and the car and yes or no. So we always give the X data, which are the features of a sports car, like the visual features of a sports car, right? So this is the parking lot. The parking lot has only the cars, right? So this is like part of the training data are the features, X. The other part of the training data is the label. So what the mother says, right? So you don't have to like understand X or Y. We will have plenty of time for that. And just this is a cool slide if you want to map it to the later knowledge you will gain, right? The child is the model we need to train because the model is what does the task later on, right? So what we give the child is always like one training example at a time. So each car with the features plus the label is called a training example, right? But very important, now that we know what a feature is, so a feature is anything, any visual property of a car, lights, color, whatever, right? In this case. And now we go back and now we want to like learn it. So we know that explicit programming has nothing to do. So we have a handcrafted model building, like a decision tree and equation. So we do everything ourselves. There is no learning, okay? So we've done that, okay? This is done. Now, this is machine learning. The two things, you can see this here. Now, this is machine learning. There are a lot of algorithms. So there's shallow machine learning and deep learning. So we want to kind of distinguish the two. And we will distinguish the two by the comment made by Tarek. Because it's very nice. So what if the mother teaches the wrong features? And then I said, in my example, the mother doesn't teach any features, right? I just said, the mother says, this car is not a sports car. And this is the difference between shallow machine learning and deep learning. Now, in shallow machine learning, or let's start with deep learning because it's the easier thing. Believe it or not, it's the easier thing here. In deep learning is my exact example, right? The mother says, hey, this is it. And the child, totally on its own, looks at the car and derives what are correct features, like what are important and non-important features, like rims, color, and it will gone away. And it will also take a combination. So if the color is red and it has these kind of rims, then that, and then goes on. So it will derive everything, child will derive everything by itself, right? So this is deep learning. Deep learning means magic. it has some problems. We will discuss them later in AIBDS2. However, deep learning is the exact analogy that I just gave you, right? Child is given a car, blah, blah, blah. Now, in shallow machine learning, what we need to do is we need to tell the child the features of the car. We do not need to tell the child what features are important. This is what the child will learn by learning, right? But we need to tell the child what features to look at, right? So we don't prioritize them, but we just say, okay, color, rims, we have to look at this. So you have to look at these 6 features. We do not give any importance how important the features are for the sports car. This is what the child learns, but we point the child, we just say, hey, these are the features, right? We do not say, if we would add the importance of the feature, then it would be explicit programming. We would say, this is like, this has a weight of 2.0, this has a weight of blah, blah, blah. And then we have an equation, right? And so this would be explicit programming. So explicit programming, everything is handcrafted. So the features are handcrafted and the weights of the features, how important they are, how they influence the actual decision is also handcrafted, right? So everything is handcrafted, called handcrafted model building. Here, what we have is we need to say, okay, these are the features, but the importance of the features, so the actual model building, is automated, right? And in deep learning, the features are automatically extracted and the model and the weights also, right? So how important these are. And if you understand that, then you understood just the core of what machine learning is and what shallow machine learning and deep learning is. And if you understood that, then actually the lecture's over, can go home. This is the main part. No. Of course, we will get a little bit more technical, but we can, as you saw for yourself, this is why I ask you to put it in the chat. Each of your comments addresses a problem that we will address using this analogy. So every problem that you said was completely valid. And we will also see that because for you now, this seems like magic, right? It seems beautiful. I don't have to, as a mother, like you said, if the mother doesn't know what the features are important, it's a problem because the problem is that we are actually part of the mother in this case, because sometimes we, as a programmer, as the people doing the model, making the models, we have to like program them. We have to find some configurations. Of course, the teaching will be done automatically, but we have to like prepare the teaching. So we are part of the mother. And if we are a bad mother, then this might result in a bad performance of the task, right? So, and I think this analogy, so in this analogy, we have basically 3 problems that can occur. Problems with the parking lot, so problems with the training data, problems with the training data in forms of features and labels. So this is part of the mother. We have to say that that in my analogy, it's a simple analogy. So the mother is also the one who trains the child. Usually the parking lot, it would be better to say that there is a third person that trains the child, or the mother is like somewhat on the parking lot that puts stickers on the car and says, this is a sports car, this is not a sports car, right? But how the child learns actually is part of the child's learning algorithm. So what I did not have here is the model, so that after the child has trained, then we get a model. What is missing is the actual learning algorithm, but I didn't want to go into detail, but that is also on the child. So the learning, because it's in yourself, how you learn, how you pass the math exam, you have the learning algorithm, right? And we can adjust. The problem is we can adjust the learning algorithm. So we're like part mother, part child in this case, right? Yeah, but we will see about this. So, but this analogy is very good for helping us to understand what there are problems in the parking lot, what problems at the model, problems that the child has. So this will help us out in a great way. So, okay. Having said that, what are some of the challenges, right? So, as I said, we will go into detail. So how we're going on from here now that you know everything, basically know everything, can go home now easy. we first get to know how AI-based systems are built, right? So it's like important to know, okay, yes, we get the concept, but how do we do it? How do we implement it? How do we, not necessarily how do we program it, but how does it work? Like, for example, how does the actual training work? So we know the input of the training are the training examples, but how does the child learn from that to to it to actually arrive at the model that we can use? This is the big question mark right now for you, right? And this is what we will learn. But before we do that, we need to address all the other things, because as I just said, uh, we are interested in how the child learns, but we also need to be interested in, first of all, the task itself. What does the child need to actually do, right? If we don't know this, so we cannot start right at the learning part. There are a lot of things around that we need to consider ourselves with first, like the task. What kind of task is it? I already said like something about classification and regression. So this is very important, because then we need to make substitute our child, because not every child can do the same task. So we need to get a new child, right? A new child that we can then train. Like some people just can't do it. So we have different model classes that we can use. You've heard about, like, we already had it, like you already saw it here. So we have different model classes. So these are model classes. Like we have support vector machines, decision trees, like these are shallow machine learning. We have also like some artificial neural networks that have like one layer or something, and then there is like the deep neural networks that have more like one layer, like convolutional neural networks. So these are model classes. So these are like the blueprints of the child, you can so to say. And then we have to train them. So they are like empty hulls. They're like around. They are like a blueprint, but you have to fill out the numbers in the blueprint, right? But you have the structure. So this is how you can imagine this. So we need to, like, it could be that we need to substitute a child at some point, right? But we need to know the task first, right? And then we can consider ourselves with how to get the training data, right? So when we know the task, we need to know, okay, once we know this exact image, we see, okay, we need some cost, and we need to label it yes or no. So this will be our task. So we need this data, and we will not start by the whole machine learning thing. We will start earlier, because this is practical relevant for you. You will never start a project just training the model. You need to care about the data first. Every practical project has to spend 70 to 80% on the parking lot, believe it or not on the training, right? So I cannot stress enough how crucial this is. And this is, since we want to get you more practical experience, we will go from task to parking lot to learning. Okay? And then to evaluating it, and then to unfortunately, going back all the way to task again. So it's an iterative process, as you might have thought. Yeah. But it's better to have a process than to just have like these loose ends. Okay. I said from time to time, so I will say, let's have a coffee talk at first 5 minutes. I think this is a good way. And then also in the last lecture, I will have some kind of summary and lessons learned. Okay. So don't worry about it. So also read O1. Okay, steps to model building. Now we want to discover these steps. So I informally told you about the steps, now what we have to consider. So you can use this slide, like you can use this for everything, right? But now there are steps for model building. So I'm going to go over some of these slides fairly quick. So if I go over a slide fairly quick, what does that mean for you, right? It means that probably it's not the most interesting slide that you should consider yourselves while learning for an exam, right? So, okay, haven't said that. Sorry, needed to cough there. Okay, so basically there are many process models that we have here, right? That describe the process of building such a model, because the machine learning model, is what solves the task for us of prediction, right? So saying this is a sports car, yes or no, right? So we want to automate it, because remember, before we do this, we want the child to do this on a parking lot it has not seen before, right? On a new, like if you have something, you have a customer you deem credit worthy or not in a bank, right? You want to automate the decision how to give out, let's say, small credit, small loans, okay? So you get all the data from the customer, and then you train a model based on old decisions, right? You have the decision you have an old decision and you have a customer, right? So you have the training example, customer and decision, credit worth, yes or no, age, debt, whatever, right? Years of work, have all the data here, right? And it's the same thing, right? So we train a model for granting loans, and this model will then be put into a system, like an online system or a user interface, where there is like some person saying, okay, and the simplest form is someone comes to the bank, wants a loan, and the teller at the bank says, hey, or the professional at the bank, the credit granting personnel, whatever this person is called, asked a bunch of questions to the person. They has never seen the person before, right? So it's probably a new person, could also be an old person, but however, the person comes in, says, hey, I want a credit. Okay, how old are you, debt, and so on. And then usually they also hand in documents, so they don't just like interview them, but it's easier as a picture. And then we'll put everything into the tool, like let's say a website, right? An internal website, intranet website, presses enter, and then the model is called that we just trained. The credit model is called that we just trained, put in every variable, every X value, and spits out the Y value, spits out credit worth yes or no. Maybe also a score or something, could also be a potential scoring, right? So that we don't have just yes or no, but we could also have yes or no. And this is how it works, right? This is how we put the model into a system. So of course, then we can also talk about the system, like does the person using the system like the system? Does it trust the system? Because in the end, the person behind the system typing in all the things and saying credit worthy yes or no is responsible for the decision to the customer, right? Because he or she gonna tell you don't get a credit or you get a credit. Get a loan, don't get a loan. Okay? And so it might be that the person doesn't trust the tool, right? But these are other issues, like I talked about. These are the soft issues. So, however, how do we arrive at this model? Because the model is what bothers us. This is at the core of the system. How we implement it then in a technical way, it's very easy nowadays. You can just deploy it. It's called deployment usually. And we'll talk about it. So there are many models, and we will use the CRISP-DM. So TLDR, too long didn't read. We will use this one, right? Because it has the best phases. Yeah. So like not doing a Trump impression has the best phases. It has the best because it has business understanding and it has deployment, right? And I like it when everything is in there because this is how it's done in practice. So usually what you would learn in a machine learning course is probably modeling and evaluation. And that's it. Not knowing how you actually arrived at how you actually get the data into modeling, right? And how you actually, I mean, we won't talk about deployment either, but you know that it's there and that it's a necessary step. It depends heavily on what you like, how you deploy it. I just can give you some options, but this is not hard to do. However, you need to concern yourself with it in practice. So we're going to start out with business understanding. So business understanding is what you always need to do. Now, if we talk about this, I want you to put yourself into the role of a data scientist that gets a project. You're a data scientist in a data science company. That means your job is every half a year you get a new project from a new customer. The customer can operate in any domain, like banking, Medicare, right? Manufacturing. So the first thing you have to do always is to understand the actual process, the actual task, and the actual business. You need to understand the problem that you need to solve. Without that, nothing will happen. If you don't understand the problem, nothing will happen. If you don't understand the context, nothing will happen. If you don't understand under which conditions the then deployed system can operate, it's very bad. Nothing will happen. And this business understanding is input for everything else. Like if you don't believe me, just think about if you don't understand the business, if you don't understand like the IT structure, how do you gonna know what kind of data you will like put in, right? So this will also be part of data understanding. But it's very important that we assess situations. So let's quickly, we will go through these phases in separate lectures. So just quickly, so we need to determine, as I said, the goals. Like, what are the goals of the business? What does the customer want? And a common problem in information systems is that you are the data science expert. You are usually not the domain expert. So you have the data science expert, this is you, and you have the other expert, this is the domain expert. So you know a lot about all this stuff, right? You know a lot about all these other 5 steps. And the domain expert knows a lot about that, right? Knows a lot about the business, maybe knows a little bit about the data, but that's it. And now you have to communicate. And usually you speak 2 different languages. And this is, and now if you can speak a little bit of the language, like of the domain expert, because you have prepared a little, or the domain expert can speak a little bit, you get together, right? So being in between chairs, like being between developers and the actual, like the customer, is a very important role. And you can also like this is a legit job, right? Well-paid job, actually. So, and the question is, what does business understanding do? Well, we will talk about this at the end of the lecture, just to say, okay, business objectives, goals, assess situations. So goals is like, what's the back? What do we have to do? Like, this is basically, what do we have to do, right? What do we have to do? And what do we have to take care of, right? And then we need to assess the situation. Like, what do we have and under which circumstances does it operate? And then we have to transform this business goal. So this is a business goal is, hey, I want to make more profit and I have all this. Usually they come to you and say, hey, I have all this data. I want to generate more profit. And maybe they say, I want to get recommendations for my customers, or I want customized ads or whatever, right? Maybe you are lucky enough that they don't just say, hey, I have all this data. How can I get business value? But this is probably a lot, right? So if you're like, they have no idea what to do with the data, or they even ask yourself, hey, not ask yourself, ask you, or ask themselves also probably before they ask you, before they decide to pay for you, for your services, is how can I even get data, right? Maybe they don't have the data yet. So you even have to suggest them how to collect data from now on from customers and whatever. To arrive there. Why do you think everybody wants your email address, wants your Google, whatever, wants you to log in with your Google account on every web page? They want your data. Your data is gold to them. They can send you customized ads. They can put it in TikTok. They can put it in Instagram. Have you ever wondered why you get so many ads that might not fit you, but usually fit you? I mean, this is it, right? So, and people will ask, hey, how can I do that, right? And then you have to translate it to data mining goals. So for example, let's take the simple example of the credit. So I will have different examples, but usually we will have the loan examples, the credit example, credit worthy, yes or no. So they say, hey, I want to automate my process of giving people, deciding on if people get a loan, yes or no. This is the task. This is what they tell you. Then they tell you, hey, look, this is what I have. We have all the documentations of all the credit requests of the last 10 years. And the important thing is that, for example, what they could also do is they could say, hey, yeah, we need to like do it in under 10 minutes per customer or something for small credits. And then you have to determine the data mining goal. So what you say is, hey, this is a classification problem. So as I said, you have to transform it into a problem where you can know, okay, what kind of system do I need? What kind of model do I need to train? What kind of data do I need? Like, how can I improve the model? So in other terms, what kind of child do I need? And to what parking lot do I need to go, right? If using the analogy, because we need the task. The task has nothing to do with cars. We don't need to go to parking lot at all. Okay. Now, and then you project plan like always. Okay. Okay, so I can skip this. So this I will skip. So we have data understanding. That means that we get an idea on how our data looks quality-wise, if there are any problems with it. if there can be any problems when we use it for our problem, like do we have these are basic data understanding helps us to identify the parking lot problems, in other terms. Data preparation fixes the parking lot problems, so identifying the problems and fixing the problems, basically. Then comes modeling. This is the teaching, where we then have the data. After this step, after the data preparation step, we hopefully have a good parking lot that we can show the child. Now we have to show the child and train the child. And then we will send the child to a new parking lot and say, hey, let's see. Let's see. And the new parking lot is the beauty of the new parking lot is that we actually know the answers for this parking lot, right? So it's a secret parking lot that the child hasn't seen before, but we have seen before. Okay. So, and then we can say, okay, we can compare what we call the ground truth. So this is like the word of the day is ground truth is actually what's really happening. So this is the true labeling. However, the true labeling could also be false. Like it's the data, right? If you say you said like if the mother labels the thing and she's wrong, then but this is what the mother does is usually considered the ground truth, right? And then we evaluate it and compare the decisions. And then if it's bad, we have to go back here. Like usually not in business understanding. But if something doesn't actually work, like for example, we take too much time that we have to, so we learn that it doesn't serve the business, we usually have to go here. But usually this is like the most often done iteration, right? Evaluation, data understanding, maybe evaluation, data preparation, maybe evaluate modeling. So the more iterations we have, the shorter circles they will be, hopefully, right? Okay, then we deploy it after it's ready. We just put it out and then the bank teller can type it in on his tool. And this is the deployment phase. All right, so that's it. These are our phases. Really, really cool. Okay, and if you want, you can read about this. So there are a lot. This is like a practical guide. It's also why we choose this model. It's a practical guide that was put out a long time ago, but I still like it. So because it's very general, but you can see here, for example, what do we need to do? Like what are these steps? And there is like this crisp DM, like this whole book about it, right? And this is like how it looks. And yeah, we can learn a lot from it. Okay, so now what I want to do is we want to start a little bit going after we know the actual process that will take us through the lecture. We need to have a look at what kind of problems we actually attach, right? So obviously this is very general. This is obviously very general. So in business understanding, as I said, what we do is, in business understanding, what we do is we have some type of data mining goal or like we need to transform it. Data mining is a little bit old school because it's very old, could talk data science goal or analytic goal or whatever. But of course, in this lecture, we need to limit like the problem space a little bit. Like there are obviously a lot of analytical problems and we cannot because they just say, hey, for example, if they say, hey, I want to cluster my customers. I want to see how they differ. This would, for example, be unsupervised learning, which is not the scope of this lecture. So what I'm going to do now is I'm going to limit it a little bit, and then we're going to compare it to other disciplines, right? So this is what we're going to do next. So this is our focus because we have to focus somehow to make it like achievable for you, for me. So we consider data science from the perspective of predictive analytics, right? So predictive analytics means, so this is very general, basically. So this means we want to predict something. We want to do exactly what I just told you. We have some training data and we train a model by supervised learning. The thing I just explained to you with a child and a mother is called supervised learning, right? Also modified for unsupervised learning. But we will get there later. So the focus is on prediction models. We will use the crisp DM. We will do classification and regression problems. We will use Python, as you might have seen from DataCamp. Okay, so very cool thing. Like we will use this guiding model, right? And there's also like this, sometimes I have optional resources, like also the reads, as you see, they are also optional. So they are in this blue shape here. Like this is optional. It can help you to understand it, or it's just purely optional. Like the read can help you to understand it. This is purely optional. Like as you see here, we have different steps. And in my example, I said every 6 months you get a new project. Like the question is, how do we allocate our time? Because if we have like 6 months, where do we put the time? Usually a lot of the time is split up between like data understanding, preparation, and modeling, right? So this is like usually the main problem area that we have here. And now this is a cool thing, which is called data-centric AI, right? So it could be, should we do more data engineering or should we do more modeling? Now the question is, and it's stated here, that we want prediction models with high accuracy predictive power. In other words, we want prediction models that predict well. If they don't predict well, they are useless. We cannot deploy them. Like now imagine we have just a bad model that says, okay, you get a credit for a person that is absolutely not credit worthy, right? We will use a lot of money, and this is not our best business objective intention, right? So we have to, this is like business understanding is, hey, we want to make money. So this means our model needs to at least fulfill like 98% or something, whatever. So this everything, every condition for modeling and also every condition for evaluation, so what the evaluation needs to reach, is in the business understanding, right? So, and this is just a nice video. You can also watch this later. So you can watch this after we finished with data preparation. So you can watch it again, or you can, but I thought it's quite nice. It's a quite nice idea on how we can allocate our time. So this is purely optional. It will not be part of the exam as indicated by the blue thingy. Okay. So, and of course we derive our lecture plan for the whole semester based on the CRISP DM. So the beauty is it gives us a structure, so you know exactly where we are. So here we are we're still in the introduction to data science, and in the introduction to predictive modeling. So data science, very special field, like very grand. We have some business goals. So this was like what we did. And now we have to go a little bit into predictive modeling. Then we go into business understanding, data understanding, and so on, right? All right. So an important note is that here we will focus usually on shallow supervised learning, right? So shallow machine learning, shallow supervised learning. And we will, after we've learned the concept of machine learning based on the easy models, because we have to start with the easy models. And it's actually not different for the deep learning models, but we have more to do there, right? So it would overwhelm you if we start with neural networks. So what we're going to do is we're going to shift the whole neural network thing. So we'll just deal with neural networks, deep learning networks in AI BDS2, right? So that we can finally explain you how ChatGPT works, and then maybe do a little explainable AI, addressing one of the problems of AI. And of course, we will talk about evaluation. So how do we actually evaluate this? All right. So now something I will go through rather fast. So we have so as you see, these are like different parts of the lectures. So the learning goal of this, let's say, partial lecture. So a lecture is not necessarily the whole 90 minutes, but it's built off of multiple lectures. So the question now is, what we did was, first thing, we had this whole process, right? So now you know how it works. And now, then I said, hey, what are we focusing on, right? What are we focusing on? And now we are in the realm of identifying. So I need to give you some knowledge that helps you identify data goals in business understanding. So this is like the theoretical precursor to the business understanding, right? Because we need to know what kind of information can we gain from what, right? Because they won't say, hey, as I said, they would say, hey, I want to make some money, or I want to get that information. Maybe they just say, I want to get that information in order to make money. Or sometimes you have to, don't even say that, and you have to determine actually what information needs to be output. And then, of course, you need to know what kind of information is yielded from what we call analytics. Like, ORBA is business analytics. And so this also deals as a general thing. Okay, so I will just show you, we have a lot of stuff here with all the analytics. What I will do is I will quickly go over them. So this right here, different types of analytics. We are concerned in this lecture with predictive analytics only. However, it's always good for you to know all the types of analytics, if you know what I mean, right? It could be very important to know that. So we start, and also they usually build upon each other, right? Usually. Descriptive, the diagnostic is a little bit, yeah. They are on the same level, but different. So descriptive analytics. Descriptive analytics is the cornerstone of every analysis because this provides the basic information of what's going on right now. So descriptive means what's going on right now, also what has happened in the past, right? But this doesn't look into the future. It just says, for example, okay, what was my revenue in the last 6 months, right? And then what you can do is, this is typical what's called business intelligence. Like, imagine you are the boss of the company that gives out the credits, right? We're sticking with the loan example, right? We're sticking with the bank example. And then you have everywhere, you have like your little banks, right? Your little banks everywhere across the towns. And like, you are the boss of all the banks, right? So you're like Deutsche Bank or something, and you have your bank in Magdeburg, you have two, then you have like in Frankfurt, everywhere across Germany. And now you want to analyze how many credits were given and how many credits were denied because you're interested in it. And then what you can do is you can see, okay, all in all, 1,500 credits were granted and 9,800 were denied, for example, right? So this is for all of Germany, for example. And then you can click into this, and then it's like it splits up, and you look like at the federal states, like Saxony or Sachsen-Anhalt or Berlin, Hamburg, whatever, right? And then you suddenly see that in Sachsen-Anhalt, where we are, like in Magdeburg, they see that, oh, they granted like 200 credits and only denied 20, just as an example, right? And then you go and you see, oh, most of that comes from the Magdeburg bank, right? So there is someone that loves to grant like these credits. Then you can go deeper into this, and you can say, hey, what are the conditions of these credits? So you can like dig deeper, right? This is typical business intelligence, and this is typical what's happening now. Now, diagnostic analysis is why this doesn't happen. So we want to do explanatory empirical modeling. This here can also write statistics. This is what you learned in your statistics class, right? So you had all of you had statistics. This basically you can write next to it if you want statistics class, right? So this is basically stat 1 plus stat 2. So usually this is stat 2, like this is statistical inference, and descriptive analytics is sometimes also stat 1, right? So usually, I cannot say for sure, but usually statistics 1 is like descriptive statistics, and this is like this one. So, and the important thing is, so this is like the first thing you can do, like you need some of these informations. This is like 2.1, and this is like 2.2. You don't have to write this down. I'm just illustrating it. I won't write too much on the slides. And this is like 3, right? So because diagnostic analysis and predictive analytics, they often use the same tools, but the goal and the aim is very different. It's like more like a philosophical difference, and also a technical at some point, because they don't have deep learning. But yeah, okay. So let's go quickly over descriptive analytics. I already told you all about it, right? So you can read this if you want, but this is basically what's happening now. Now, diagnostic analytics is like, what we do is like, usually we can also use business intelligence for that. We can like diagnose ourselves. Where does something come from? What was the development? But usually we have a statistical approach building explanatory models. For example, you will have like a statistical test and say, is the credit, the distribution between given credits and not given credits significantly different in sorry, in Magdeburg than in other cities, for example, right? This would be a model you can use. So they would say, yes, it is. And then you can go deeper and can look at the variables of the Magdeburg bank compared to other banks and see whether they are different. Like you can build a model and say, okay, what is the influence factor here? Is it significant? Yes, no, and so on, right? Now, predictive analytics. So the goal here, basically, if you have like a model, like we always have a model. So we model this. So this is, for example, if we give credit or not, and then we have some kind of function of a lot of variables. Like I'm going to say we have 3 variables here, right? So this is, for example, if we have credit worthy, yes, no. So credit, yes or no. And this could be, for example, this could be how much money you have on your account. So account money. This could be age. And this could be maybe how many years you're working. Working years, okay? Just an example. And now in diagnostic analytics, right? In diagnostic analytics, we are interested in the relation of X and Y. So we're specifically interested, what's the influence of X on Y? So we try to find an explanation why sometimes Y behaves that way and Y behaves that way. And this is why we model it. So in here, in predictive analytics, it's the same thing, right? We build a model, the same variables, right? The same variables. But we are only interested in the quality of Y or the estimate for Y using our model. So this is actually an estimate. So we're only interested in the quality of the prediction. We don't care about the influence, right? And this is why usually we also love to throw more data in here. Also, it might have nothing to do with this, right? So the idea here is to select our variables based on experts, based on theoretical ideas, like, okay, the working years, the age could something to do. And here, this could be like totally unrelated data, right? Because we throw the whole database in there. It's a little bit more difficult than this. We still have to select this, but we might not be selective because here we just want to know the influence of these 3 variables. So we are not interested here if this is a good prediction, if they predict it well. We're just interested if there's a significant influence of this factor. And we are actually not interested in knowing that this whole model is a good one, right? Like we will analyze this with R square, you might have heard from regression, but actually we're only interested in the single factor influences. So, and here we're just interested in the quality of the prediction. We want a good prediction. We want the model to have a good prediction. This is why the evaluation of predictive analytics and statistical analytics is different. So, but the basic idea of modeling like credit decisions is the same, right? But it's right. And the important thing in predictive analytics is mostly forward looking. So we look into the future. So if we want to say we want to grant credits, we've never, basically the future thing you can see, we've never seen the customer before. Like we have seen customers in the past and we can describe them. So we can describe with descriptive analytics, we can describe every credit card decision that was ever made. Like I just said, like we can look at Magdeburg, we can look at the rest of Germany, no problem. But we cannot look into the future. But this is basically saying, okay, if we grant you the loan, we expect you to pay it back in the future. So the model actually determines that it's paid back in the future. So either we are having a forward-looking approach or an approach where we say we've never encountered this before and we don't know, right? So this is the whole thing, right? And yeah, this is predictive analytics, this is predictive modeling. Okay. And then there's prescriptive analytics. So that's most sophisticated form of analytics, but I will show you this right here because it's a nicer picture and it's blatantly stolen from Wikipedia, but I actually like this. You remember that one? You remember this at the beginning? And I said, okay, predictive analytics helps us to predict these probabilities, right? So we can predict whether set 1 or set 2 will occur. And then we can choose an action. So this is like predictive analytics, right? Predictive analytics. And also what will happen if I choose this and this these numbers here, like what will happen if this happens or this happens. This could be from historical, so this could even be descriptive analytics. This could be descriptive analytics, or it could also be predicted, right? If I have a prediction model for that. But this could be both. But let alone that there is a number for this makes it, first of all, we need to describe it and then we can predict it. And choosing an action right here, this is prescriptive analytics. This is prescriptive analytics. So prescriptive means we're choosing an action. Like, for example, we have a prediction and then we make a decision, right? So prediction, we have predictive analytics, right? And so actually, I would say prescriptive analytics, sometimes this is part of it, right? So this can be part of it, but usually prescriptive analytics starts here, right? So sometimes they are included. So it's not wrong to include them. Because we have something like contextual optimization where you put the prediction into the prescription. So this very advanced technique of optimization. But usually I find it easier to say, okay, prescription means we're choosing an action. So this is basically what you learn in OR, like in Marlon Ulmer's class, in Janis Neufeld's class, Rainer Kleber. So this is what you learn when you join this class, predictive analytics. And descriptive analytics is everything that you learn when you have like controlling, for example. Controlling accounting, right? This is like descriptive. Okay, so and now you know, and this is very important to me, to always connect to other peers, like to other colleagues and what you learn from them, because everything is important, but it needs to be connected. It needs to be connected. And we are considered with predictive analytics, but of course, this and this helps to us to choose an action, which ultimately is our goal. This is why I started last time with exactly this. This is our goal. And this is also what we will analyze in the business understanding. Like they will say, hey, we have to make this decision. How can you support us? Usually this is what they say. They don't say, oh, we need a classification model for this. Nobody will say that, right? No, they will just say, hey, we need like to help with that decision. We need to automate this decision. Sorry. So this is the idea here. Okay. And so this is how they work all together. Like, and if you know that, if you know how they work all together and what they are, then you're Gucci. Okay. Now, what I want to do, so as you see, this is context. Like the first context was to say, okay, what kind of analytics are there? So that we know, okay, what do we need? What scope do we need, right? So how does it put this in context, right? So how do we put this in context? Well, if we always remember, you are a data scientist, you get a job. Now you have to determine what you have to do. Sometimes it could be that they say, hey, I want to look at my numbers from last year. Then you need to implement a business intelligence tool. You don't have to do diagnostic, predictive, or prescriptive analytics. So we're teaching you this because in practice, it's not like, hey, we want to do predictive analytics and we need to implement a deep learning network model and you are our guy. This is not what will happen. They don't know about this stuff. They don't know. And even if they know about it, it's not suitable. It's like you coming to a doctor with your Google diagnosis, right? And saying, hey, I think I have a bad disease because my toe itches or something, right? So, and this is why you need to know that. But in this class, of course, we will prepare you for the case when you analyze that what the customer wants is predictive analytics. However, I need to tell you what other forms there are, right? So, and now we are in predictive analytics, right? So we are in predictive analytics. So we had types of analytics, and now we said we focus on predictive analytics, and now we are in predictive analytics, all right? And now we look at what kind of problems are there and how can we teach the actual child, right? So what kind of machine learning are there? What kinds of machine learning are there? So, and it's pretty easy. The first thing I already explained to you. This is the whole child and mother scenario. So this is basically the child, mother, sports car thing, right? Okay. And now, so I don't need to explain it again. You can read about this. So we have training data, then we train the algorithm, we evaluate it. If it's good, we don't do it again, and so on, right? So in other words, supervised learning, you can have this beautiful graph here where we get a little bit more technical. So let's say we do the credit scoring again, right? Credit scoring again. So let's say I have two variables of each customer that comes into my bank. And this is, for example, the income. Let's say income is X1, right? Let's say this is income. And I have age. This is X2, right? So I have two features. Features are always denoted by X, right? So these are features. So features are variables that help me to predict it, right? So this is like information that help me to get an idea on whether I want to give this guy credit or not. So we have two features here. So now you're asking, where's the Y variable? Where's the Y variable? Well, the Y variable is hidden here. So the Y variable is hidden here. So we've marked this. So this is basically gets a credit, yes, and this is basically does not get a credit, no. Okay, so this doesn't make sense because it's reverse, so this is a bad bank, but we will keep it that way. So this is yes and no. So what we're gonna do is we're gonna look at this, and this is supervised learning, is to distinguish these from them, the X's from the O's, right? So in this case, so this is a classification, by the way. So regression looks different, but we don't. So basically, the goal of supervised learning is to do this. This is our model, right? In this case, it's just a binary decision boundary. Okay, so this helps us distinguish. And now, so let's say this is our training data, and now there comes a new customer that I have not seen before. And we don't know if the customer is an X or an O yet, right? So we just have a new customer, and the customer, but what we can know from the customer is we know X2 and X1 from the customer, right? So let's say we have a customer. I'm gonna draw him like a little human. So this customer is right here. So it has X1 like here, and it has X2 here. So, and now we put these values into the model, and we see that is left from this thing, and we can say this guy is definitely a no. It's definitely a yes. All right. So this is what supervised learning is. And unsupervised learning, we have to pay a little more attention because we will talk about supervised learning every day. Unsupervised learning means specifically, like in the example with a child, we go to the parking lot and say, this is a car, this is not a car. In unsupervised learning, we don't say that. In unsupervised learning, we just let the child go to the parking lot alone, and the child has to look at the cars and has to group similar cars into groups, right? So we just have X and we don't have a label. So no Y, no label, right? So unsupervised learning means we just have X and we have to find like commonalities only based on the features. So basically here I have two buckets in front of me, and my task is to throw a new customer in the one bucket or the other bucket. Now here I create buckets basically, right? I need to create buckets. So, and I need to put in similar people in in one bucket and people that differ in another bucket, right? So this is unsupervised learning. You know that from cluster analysis. So examples are this. I have a lot of examples, of course. Examples here are, for example, I am again, we're with the bank, and I want to cluster my customers based on all their variables. Like could also be these variables, income, age, whatever I have of them, so that I can send them individual offers, individual ads that say, hey, listen to me. Wouldn't you like to invest in ESFs or something, or in crypto? You look like a person that wants to lose all the money. Okay. Or gain a lot, whatever, right? Not dissing crypto people. I'm just poor and I don't do it, so I'm jealous. So, all right. And this is cluster analysis. So there is no label. Like we built the buckets and here we have the buckets. Okay. So that's the difference. And I think this is actually a nice way. So here, these are just some additional, you can see some additional explanations if you need some cool opticals. So basically, what is the output? So the output here is whether they will have a heart attack, and the output here is really cool. So here we will have clusters. So we get basically a new column that says, okay, these people go to this cluster, to this cluster, and so on. Right? All right. So next time we will quickly go over. So as I said, we didn't make it to business understanding, but next time we will do explanatory statistical modeling with predictive modeling, because as you might have seen, I said, was it this slide? Yeah, I said they are quite similar. This is why I said 2-1 and 2-2. And I want to explain this a little bit more in detail, what's different, but we won't allocate too much time. We won't allocate too much time onto this. And then what we will do is we will go into business understanding, and then we will also start data understanding, right? To get the ball rolling. But we have more than enough time. It's important to ease you in a little bit. And so next time, our learning goal is, how is machine learning different from statistics class? You took statistics class, right? Right? Please tell me you took statistics classes, please. All right. With that, we're done for today. Thank you, everyone, for joining. I'm overwhelmed, by the way, by the number of people stepping up here. I know they will be less and less, and it's totally fine. It's okay. Just a quick reminder, and I want to keep this on video on demand. You've checked my mail. I've updated the data camp, so I needed to create a new data camp link because the old expired. Simple as that. So if you have not signed up for data camp and you're watching this at home or you are here right now, the link is valid until 29th of October. This is the last deadline. After that, you're done, right? So I hope I hope you appreciate it that we like deliberated a little bit, expanded the deadline a little bit, because every time we do this, we have to, just so you know, that it costs us a lot of work. People that come after the deadline, we have to manually adjust your license. This is why some of you actually ran into the problem of having like this, we need to pay for the next class thing. We have to manually do that. And maybe I will show you just next time how it jumps from page to page. And if I change something, it goes back to page 1. So if I'm at page 5 of all of you people, and I change one single license, it goes back to page 1, and I can only select up to page 5. So I have to click, if I want to go to page 8, I have to click 5, 7, 8, and then I change it again. So just so you know, and we want to put our resources more into teaching you and preparing the lectures, having these analogies prepared for you. So if you would endorse us, please register until October 29. Okay, that's it from me. If you have any questions, thank you so much for joining. See you next week, everyone.